Good day, everybody. How are you all? Hope you are doing great today. I'm feeling great today, and we are going to continue our discussion on fitting a straight line through data points. This process is called regression because we are fitting a straight line. It is called linear regression. The term linear comes from the word straight line. So we are fitting a line to the data points that we have collected by variable data because we have a x and a corresponding y paired data points. We're going to fit a straight line. We have determined correlation coefficient, strength of the relationship between x and y. Now we have fitted a line. We want to find out how good is this fit. That is the primary purpose of this presentation. How good is the fit? You may have fitted a line. You may have wondered, did I do a good job? Is it a good fit? How do I assess that? That's what we are going to discuss. So please, my request is to hang around till the end of the video. It is a short and sweet presentation, not too long. Please stick around till the end. I will promise I'll give you some important tips at the end of this program. Please hang around with me. Please bear with me. I appreciate that. And please subscribe to my channel by hitting the red subscribe button. I have quite a bit of presentation on statistics. Okay, so let's get started. I worked all kinds of problems just for you. So we know we can find the vertical distance of a point from the fitted line. We discussed that last time. How do we do that? We take the value of x of the paired data points, plug it in the equation of the fitted line. So suppose x1 is the x coordinate or x value of data point 1. Take that x1 value, multiply it with the slope, and then add the intercept. You will get y1 with a hat at the top is the predicted y1. Now you know all the points will not fall on the straight line. Some will be above the line, some will be below the line, some of the points. So points which are above the fitted line, the vertical distance from the actual point to the fitted line is positive. And that is y1 minus y1 hat. y1 hat is the predicted value of y, which is below on the line, and y1 is above the line. So that vertical distance is positive for points which are on the line. For points which are below the fitted line, this vertical distance will be negative. This vertical distance between the actual y value and the predicted y value is called the residual. Again, repeating, for points which are above the line, the vertical distance is positive. For points which are below the line, vertical distance of the point from the line is negative. Also, I mentioned last time that if you square a negative number, it becomes positive, such as if the vertical distance is -2 because the point is 2 units below the line. But if you square -2, that is -2 times -2, it's 4. So usually we square the residual. What is the residual? Actual value of y minus the predicted value of y from the fitted line. But we get it by plugging the value of x in the equation of the line. Okay. So when a point is above the line, the residual or the vertical distance of the point from the line is positive. When the second point x2, y2 is below the line, vertical distance of the point from the line is negative. And these vertical values or distances are called residuals. The predicted values result from substituting each sample x value into the equation of the least square line. Okay. So the distance between the actual y1 value and the predicted y1 value, actual minus predicted, is the first residual. Okay. So each residual is the difference between an actual or observed value minus the predicted value. Residual plot is a plot of vertical distance for each point versus x. A desirable residual plot exhibits no particular pattern. So if we make a residual plot that is residual or y minus y hat, actual y minus predicted y, on the vertical axis versus the corresponding x, we should not see any pattern on that plot. That is called a residual plot. Curvature in residual plot indicates a non-linear xy relationship, suggesting a curve is more suitable description than a straight line. So, consider x is age in years and y weight in kilogram of 12 black bears in a 2000. So, x is age, y is weight. Data comes from a sample of black bears. So, first we will enter the x data, age data in L1, y corresponding weight data in L2. Paired data points, x is age, y is weight. So first thing, clear the memories of the calculator. Second button, then plus on top of enter, then number 4. Clear all list, done. Then stat 1. X values in L1. So let's enter all the X values. 10.5, 6.5, 28.5, 10.5, 6.5, 7.5, 6.5, 5.5, 10.5, 6.5, 28.5, and 10.5. Okay, so I have entered all the X values in L1. My cursor, which is the black rectangle, is sitting on the 13th line in L1. I press the right cursor key over here on the top right corner to move it to the first line in L2, where I will enter the weight data, the corresponding Y values. So I start with 54, then 40, then 62, then 51, then 55, then 56, then 62, then 42, then 54, then 40, then 62, then 51. So I have all the x and y values, x in L1 corresponding y in L2. These are paired data points. Let's first draw a scatter plot. So I'll press the second button and then y equal to. And then press number 1, flashing on. Second type should be on the first type of chart. First type of chart. Then what do? Press the zoom button, which is the third key in the extreme top row. Zoom and 9. And we see generally going up the hill, there's a little bit of scatter in the data, but generally we are going up the hill. That means as x increases, age increases, weight also increases with some deviations. Now, we can of course calculate the r and r square, but that does not tell us how good is the fit. The goodness of the fit in this case will be given by the residual plot. What is residual plot? It is the residual on the vertical axis and the corresponding x values on the horizontal axis. What is residual? It is the difference between actual y value, which is weight, minus the corresponding predicted y value, y minus y hat. Observed y value minus the predicted y value. How will I get the predicted y value? Take the x value of 10.5, plug it in the equation, I'll get the predicted y. So observed minus predicted is the residual. Remember, for points which are above the fitted line, residual is positive. For points which are below the line, residual is negative. So I need to calculate the residual observed minus the predicted value in each for each of the x values. Okay, how do I do that? So I go to stat 1. I see L1 and L2. Okay, data in L1, data x data in L1, y data in L2. In x3 I will calculate the residual, and there is a particular way of doing it. Press the right cursor key, bring the cursor on the first line in L3. This is important. After bringing it to the first line in L3, press the up cursor key so that now the cursor is in L3. The black rectangle is now flashing where L3 is written on the calculator. Now press second button on the top left, second and stat button, second and stat button. Okay, notice number 7 is residual. So scroll down to number 7. Second and stat button, scroll down to RESID. All this you move the cursor to L3, then second and stat button, you move down to 7 which is resid, move the cursor down to resid and hit enter. Look at the bottom left of your calculator. You have L3 equal to resid. Now hit enter. Nothing happened. Okay. So first, let's do the regression on this. Okay. So press the stat button, then highlight calc on the top row, then number 4, stat calc, number 4, linreg ax plus b. Scroll down to calculate and hit enter. So you have to do the regression before you calculate the residual. So the regression line equation is through stat calc number 4, y equal to ax plus b. A is 0.595, b is 45.57, r value is 0.6, going up the hill positive, moderate positive correlation between x and y. Now you will do what I was supposed to do. Stat 1, move the cursor to the first line in L3, then up cursor key to go to where L3 is written. Okay. Then second and stat button, second on the top left, stat on the second row. Then number 7 is resid. So second, stat, number 7, resid. At the bottom of your screen, we have L3 equal to resid. Hit enter. Now your L3 is filled with resid or residual, which is the difference between actual y, observed y, and predicted y for each x value. Now you are going to make a scatter plot between x on the horizontal axis and resid on the vertical axis. So how do you do that? Press the second button and y equal to key. Number 1 on, number 2 type is the scatter plot. X list is L1, fine, but Y list should not be L2 now. You want to plot resid which is in L3. So change the Y list to L3 from L2. How do you do that? Bring the cursor on top of L2 in Y list and hit second button and 3, and that makes it L3. And then do zoom 9 and you will see a resid plot. See, the horizontal line is the x-axis, y equal to 0 on that equation of that line, horizontal line in the middle. You have some points above the line, that means resid is positive, some points below the horizontal line. Equal amount of distribution. Some are positive, some are negative below the line. So there is no particular pattern in resid, which tells me linear regression is a good fit here. Let's see. Okay. So they're finding out observation. They're saying this one is an influential point, this one is another influential observation. So remove these 2 points and redo the calculation. Okay. Why? These are outliers. The first one on the top left and the last one on the top bottom right or middle right is these two are outliers. So remove those 2 points, redo the calculation, you'll get a much better straight line fit and a much better receipt plot. Okay. Now we want to calculate coefficient of determination. That is, what percentage of the variation in y can be explained by variation in x or can be explained by the linear regression model. Again, R square is called coefficient of determination, which means what percentage of the variation or variability in y can be explained or can be attributed to the linear regression model between x and y. That is R square. How do we do that? In the calculator, stat, calc, and then number 4, lin reg ax plus b, and you go down to calculate and hit enter, and you will get r at the bottom and r square. Notice here r square is 36.1.361. Multiply that by 100%. Decimal shifts two places to the right, or 36.1% of the variation in y can be explained by the linear regression model between x and y. This is the formula for it. I will not go into the formula. Only thing you have to remember is multiply r square by 1 to get the percentage of the variation in y that can be explained by the linear regression model. And we can get a standard deviation about the least square line, average variation from the least square line by this formula. Our calculators can get it directly. So this is another data set, 2021 data set on 6-year graduation rates, institutional or instructional expenditure per full-time student, and student faculty ratio in for 11 Western US public universities with 10,000 to 20,000 enrollments. And we are going to get a fit between educational expenditure and what is this graduation rate. So x is your educational, uh, x is your instructional expenditure, which is column 2. Notice here x is not the first column. X is the instructional expenditure on the second column that goes in L1. Y is L2. Okay, this is the graduation rate. That is graduation rate, we are assuming, depends on instructional expenditure, which is x. First column is y, dependent variable. Second column is x, independent variable. Let's enter the data in L1, x and y. Second column is x, first column is y. So clear the memory of the calculator. Second plus 4. Clear all this, done. And then stat 1. Enter x in L1. Okay, so 5078, 6040, 4766, 4770, 5918, 5570, 5979, 7762, 5368, 11,581, and 9,388. Okay, these are the x values. Move the cursor by the right cursor key to the first line in L2, where we'll enter the graduation rate, which is y dependent. It is assumed that the graduation rate depends on instructional expenditure. Okay, so first number in L2 is 43, next is 67, then 44, then 50, then 55, then 54, then 59, then 57, then 54, then 75, and 68. Let's do a scatter plot first. So second y equal to on top of it, then number 1, plot 1 is on, type is the zoom plot, but x list is L1, there is no L3 here, so change the y list to L2 by second and 2. So x list is L1, y list is L2, then zoom 9. And we are going up the hill, much like what they have over here, going up the hill. So let's fit a straight line through this data point. So we will do stat, calc, number 4, x list is L1, y list is L2, and we will calculate. And the least square regression line is y equal to 0.008 times 0.0038 times x plus 31.66, much like what they have on the. So 0.0038 times x is the instructional expenditure, x plus in the intercept is 31.66. Okay, so your R value is 0.83, which is a strong positive linear correlation. What does it mean? As x increases, y also increases. R square value is zero point 0.7 multiplied by 100, or 70% of the variation in y, which is graduation rate, can be explained by the linear regression model between x and y, which is pretty decent. Only 30% cannot be explained. How did I get 30%? 100 minus 70% is R square value is 30%. That cannot be explained. What 30% of the variation in y cannot be explained. Now let's do a receipt plot. This is a good regression, good fit, so we expect to see no pattern in the residual plot. So again, we go to stat 1. Move the cursor to the first line in L3 by the right cursor key, then move it up to where L3 is written by up cursor key. Then you are going to press the second button and the stat key on the second row, and then go down to number 7. You can press the number 7 key in your calculator. You're automatically on. Look at the bottom left, you have L3 equal to resid. Hit enter. L3 is filled. That is the key thing here. First do the regression, then do the residual calculation. What is residual? Difference between the actual y, observed y, and the predicted y. Points which are above the line, resid is positive. Points which are below the line, resid is negative. Now we are going to do a scatter plot. So second y equal to number 1, type is on, uh, first line is on, type is the first type of chart. X list is L1, but Y list should be changed to L3 by second and 3. Then you do zoom 9. In this case, you'll have recede on the y-axis and x values on the horizontal axis. Notice the line in the center is the x-axis, y equal to 0. Points which are above that line, the recede is positive. Points which are below the line, recede is negative. Ideally, you would want to see equal number of points on top of the horizontal line, y equal to 0. Same number of points, close to same number of points, bottom of the line also, which is the case also. There may be some influential points which you may want to do, especially the point on the extreme right is an influential point or an outlier. You can remove it and redo the calculation. But here you have almost equal number of points above the line y equal to 0, and equal number of points or residual values below the line, negative residual values. Above means positive residual values. What is residual? Distance between the point, actual observed y value, and the fitted line. Points which are above the line, recede is positive, above the y equal to 0. Points which are below the line, recede is negative. You want to see no particular pattern. Equal number of points above the line as below the line. In that case, it means the regression model is good, the straight line fit is good. Okay? No particular pattern in the residual plot. I don't know whether they haven't. So they did not do the residual plot. So I think So question is, how do I calculate standard SE? It is a standard deviation of a particular point from the line. That can be done by, if you do stat, press the stat button, then highlight test on the top row. Then you scroll down to Lin. You have scrolled down, it's not in the first screen. So down arrow key till you see Lin reg t-test, Lin reg t-test, which is F as in Frank. Scroll down, stat test, not stat cal, stat test. Scroll down to Lin reg t-test, linear regression t-test, and hit enter. X list is L1, Y list is L2, and you go down to calculate and hit enter. And you see an S value of 5.72. It is called standard error. It means this is an average deviation of a point, average deviation of an actual point from the fitted line. Okay. And this SE value we got is 5.71. They're saying is small. Okay. That's it. So what is the hint tip I want to give you? First, you can enter the X value in L1, second the Y value in L2, do stat calc 4 lin reg ax plus b, get the equation of the line y equal to ax plus b. A is the slope coefficient of x, number in front of x, b is the intercept. Also get the value of r, which is correlation coefficient. If x increases as y increases, r will be positive. Closer r is to 1, stronger is the positive linear relationship. If r is close to -1, strong negative linear relationship. Then we look at r square, which is a measure of the strength of the fit. The first one, r, is the strength of correlation, strength of the relation. The other is strength of the fit of the line. And r square, whatever number you get in decimal, remember for r square, you have to multiply it by 100%. So if r square is 0.7, multiplied by 100 becomes 70%. 70% of the variation in y can be explained by the least square regression model between x and y. Remaining 30% cannot be explained. Okay. Then we can do a residual plot. So after doing the regression, we bring the cursor on the top line where L3 is written, then second and stat. You get a list, go down to number 7, hit enter. At the bottom of your calculator, you have L3 equal to resid, hit enter. L3 is filled up with resid. Then make a scatter plot between L1 as x and L3 as y. You will see a horizontal line, that is the x-axis, y equal to 0. You want to see equal number of points, almost equal, not always, above the line as below the line. No particular pattern. That means the linear regression model is a good fit between x and y. So that's a residual plot. Residual on the y-axis, x values on the x-axis. Our goal is not to see any particular pattern. Okay. And then you can also calculate SC by, here you have to do stat, not calc, test. And then you scroll down to lin reg t-test, linear regression t-test. At the bottom of the screen of results, you will see SC called standard error. What does it mean? It's an average deviation of a point from the fitted line. You want to keep that low. What does that mean? That means the points are clustered close to the straight line, fitted line. So I'm going to stop here today. I hope you like my presentation and you'll give me a hearty thumbs up. I really appreciate that. Okay. And please let me know where you are watching this video from. That is, I'm always curious to know where people are observing my video from. And if you like this video, share with your friends. If you like my video, give me thumbs up, write a positive comment. I will answer your question if you have any question. And please do not forget to click on the subscribe button, which is at the bottom right corner. And at the same time, please click on the notify bell button. That makes you will be notified every time I upload a new video, which is almost every day. And if you like to see any other presentation, write me a note. I will do that. I'll try my best to help you out. And please do not forget to watch me tomorrow when I'll be back with another interesting video. Thanks for watching. Take care. Have a nice day. See you tomorrow.